In section 2.2, we're going to go over looking at formulas and inputs and outputs. And we're also going to get pretty good at using our calculators. So if we were to find a formula that relates the distance it takes an average car to stop when the brakes are applied, and the speed at which the car is traveling, which would be the input and which would be the output. So the car is going really fast. It's going to take a long time to stop. The car is put going slow. It's not going to take as long to stop. So what is the distance it's going to take to stop? Well, that depends. That depends on the speed. That depends on how fast the car has been going. So that means speed is independent. Once you know how fast the car is traveling, then what relies or depends on how fast the car is going is the distance. So we would say speed is the independent variable, and the distance it takes to stop is the dependent variable, because the distance it takes to stop will depend on how fast the car was traveling. So the input would be speed. You input, you tell me how fast the car is going. The output, the result, the final calculation would be the distance. So speed is the input. You say how fast the car is going, and the distance to stop is the output, the resulting calculation. And here they're actually going to give us this formula that they can tell how long it takes for a car to stop based on its speed, and the distance it takes to stop is going to equal how fast the car is going, R is the speed, how fast the car is going, plus 0.05 times how fast the car is going squared. The distance is going to equal how fast the car is going plus 0.05 times how fast the car is going squared. So if they give us that formula and they want us to fill in this table, we could do this table and put in a 5. And whatever that answer is, put there. And then we could put in a 10 if the car's going 10 miles an hour. 10 squared, and we could do that all the way down, let's say to 50, traveling 50 miles an hour. But we're going to use our calculator to generate this table. So here's my graphing calculator. So you see this y equals, that's where I'm going to put in my calculation. I'm going to go ahead and turn that off. And see this X button right here? That's my variable button. So my equation is going to be X plus 0.05 X, and here's my squared button right here. And I'm going to press enter. So in my y equation, I have the speed plus 0.05 times the speed squared. Now the calculator can automatically generate a table. See how there's a table button here? If I press the blue key and then table, it will generate a table. But I want to change the table settings. See the blue setting here that says table set? Let me change the table settings. We want to start our table at 5. And the change in every row at the table, here is 5, 10, 15, 20, 25, 30. We're going to change by 5. The independent is going to be automatically generated. The calculator is going to do 5, then 10, then 15, then 20. Then it's going to go all the way up. So now I can press my table button, which is second graph. And here's my table. with the stopping distances based on 5 miles an hour, 10, 15, 20, exactly what this problem was asking for. So, if you travel at 5 miles an hour, it stops at 6.25 feet. 10 miles an hour stops in 15 feet. 15 miles an hour is 26.25. 20 miles an hour is 40. 25 is 56.25. 30 miles an hour, it's going to take 75 feet to stop. 35 miles an hour, it takes 96.25 feet to stop. 40 miles an hour, it takes 120 feet to stop. Going at 45 miles an hour, it's going to take 146.25 feet to stop. Traveling at 50 miles an hour, it's going to take 175 feet for the car to stop. So that's using the table function of our calculators. We'll let the calculator come up with this table so we don't have to do all of these calculations separately. So now we're going to use this table to answer the next few questions. If your car is driving at 25 miles an hour, so that's right here, in a school zone, and a child runs out in front of you, how much distance will your car cover before stopping? Well, at 25 miles an hour, it's going to cover 56.25 feet before stopping. Question number 4. How slow would you have to go in order to decrease that stopping distance by 30 feet? Okay, so 56.25 minus 30 is 26.25. If I want to decrease this to 26.25 feet, I'd have to be going at 15 miles per hour. You go up to your table and find 26.25, and we would say that that's got to go to 15 miles per hour. You were doing 25. You got to go down to 15 miles an hour. At the scene of an accident, a traffic investigator determines that the stopping distance for one of the cars involved was 103 feet. The speed limit in that area was 30 miles per hour, and the conditions were ideal. Was the driver speeding? So it took him 103 feet to stop. We look here, and we find 103. 103 is not on there, but we do know that 103 falls between 35 and 40 miles per hour. So we know our driver was going between 35 miles per hour, more than 35, and 40 miles per hour. It took him 103 feet to stop. Now, if the speed limit is 30 miles per hour, he was definitely speeding. Definitely going faster than 30 miles per hour. The driver was definitely speeding. All right, question number 6. According to the U.S. Department of Transportation in 2014, 3,179 people were killed and 431,000 injured in motor vehicle crashes involving distracted drivers. If you're sending a text while driving on the freeway at 67 miles per hour, how much stopping distance will you need to avoid the accident? So my distance is going to equal 67 plus 0.05 times 67 squared. So if we put that in our calculator, 67 plus 0.05 times 67 squared you're going to need 291.45 feet, almost 300 feet to stop. What are some other factors that would affect stopping distance? So in both the reaction time of the driver and the time needed to come to a complete stop after braking. Well, it could be weather conditions, road conditions, lighting, time of day. That's an opinion question. A lot of different answers to that question.